Okay, this is the question. You're given this divided by this equals to p squared. Now, you need to understand what p and k represents. So p and k, they are integers, meaning that they are very nice numbers. And no fraction, no decimal. And then p is as large as possible. That means they want this p to be as large as possible. So when you square root both sides, right, this should be the smallest, because if this is the biggest, in order to get the biggest, right, you must divide this by the smallest. Okay, so they are actually indirectly telling you that this must be the smallest k. Okay, so I can add in here smallest k also, right? Okay, once you have understood this, we are ready to do the question. Now you see a square here. So if I want to find p, I of course need to take square root both sides, right? Which means that indirectly they are trying to tell you that they want this divided by this to be a perfect square. Okay, and the only way you can do it without using calculator and all that, right, is to do prime factorization. Okay, and I've written this as this over this. Now our job is to determine what k should be. Now, it is not possible to find p first because you don't even know what k is, right? So that's why you must find this first. Okay, now you know that this whole number, this whole fraction, right, must be a perfect square. That means the power, okay, of each of these prime factors 2, 3, 5 must be even. So this is already even. We are happy with this. We leave this alone. Why leave it alone? Why can't I have k equal 2 square and then I get rid of this? Because if it's 2 square, the number will get bigger, the k will get bigger, right? So your k must be the least value of k. So we don't want too many numbers to be parked under k. Okay, but for this second term, we have no choice but to put 3. Okay, I could have put 3 to the power of 3, right? Okay, 3 to the power of 3, I get 3 square. That works also, but it's not the least. Okay, that's the reason why we choose 3. Now, so this one done already. This with this will give me this, right? Now, the last one is I have to get rid of this because now it's power 1. It's not going to be a nice integer if I were to square root both sides. This must be multiples of 2, so I must times 5 here, which means that the least k is 15. So that's your answer. Okay, now once you've gotten this, you can just take this divided by this, then you square root and you will get your p. That's all. Okay, that's for this part. Now for the second part, you need to understand. Okay, you read the question first. For this particular question, you're given the LCM of two numbers, HCF of these two numbers, and both the numbers are greater than 405. They want you to find these two numbers. Okay, so I have written here the prime factors of these two numbers here, which are the HCF and the LCM respectively. Now, I'm going to give you one example in order to help you understand this better. Let's say you're given this number P and Q. Example, this is a totally, okay, I don't write P and Q. I write A and B. This is a totally brand new example. Nothing to do with the question that I just went through here. Okay, now if you take a look at this, if I give you these two numbers, then I ask you to find the HCF and then the LCM. Now, how do you do that? It's very simple. HCF, right, is, if you remember, I don't know whether you learned this in lower sec, right? Let's say 20 and let's say maybe 45. You want to find the HCF. What do? You must make sure that this prime factor that you are dividing by applies to both. That means what? You have 2, I must have 2. You see, I have 2, but this value doesn't have 2, so cannot. So it's 3. 3 cannot, 8 cannot also. So 5. correct? So 5 is the first one, so then it will be 4, this will be 9. After that you find that, oh, cannot already, so your HCF is 5. Okay, I hope you remember this. I don't know whether you use this method. Which means HCF, right, the concept is this. What I have, you must have. Okay? What I have, you must have. That's what it's saying here. But okay, so 2, I don't have 2. Yeah, I don't have 2. So cannot. No 2 here. Okay? Then I have 3 square, you have 3 to the power of 4. We take the lower power one. Why? Because I have 3, you have 3, I have another 3, you have another 3, that's it. I don't have another 3, so our common factor is just 3 square. Okay, now next I have 5, you have 5, then how? Just take the 5. Okay, I have 7 square, you don't even have a 7, forget it, no need to write. Okay, I have 11, you have 11 cube, take the one that is lower power, so that's your HCF. Alright, now what about LCM? LCM is the exact opposite. Okay, you take the higher power out the 2, so it is just 2 square times 3 to the power 4 times, when it's like that, right, you just take 5. Okay, then you just take, when it's like that, you take the higher power one. Okay, so this is what we call LCM and HCF. Okay, now once you understand this, because this is moving forward. Remember I told you maths is about moving forward, and then the harder one is moving backwards. So this is the harder one where they move backwards. They didn't give you the two numbers, meaning to say they didn't give you the A and the B. They want you to, they give you these, and they want you to find A and a B, these two. Okay, so how do you do it? You see, first number. Okay, I just write first number. Okay, you know that the number, whichever number, you know that both of them must have 3 to the power of 4, 3 to the power of 5, minimally. That means this fella, right, must have 3 to the power of 4 plus maybe something. We don't know. Maybe you don't have, and 5 to the power of 1 plus something. That means it can be more than this, but minimally both of them must have 3 to the power of 4 times 5. Okay? Now, what is 3 to the power of 4 times 5 is exactly 405. But they say that both the numbers are greater than 405. So how? So, what do I put here? Can I put 2 here? Okay, you try first. If you put 2 here, you'll be higher, you'll be greater than 405, right? Satisfy the condition, right? Okay, then you think about it. If I put 2 here, then the next number, right, I will have 2 square. Cannot. Why cannot? Because if I put 2 here, I will need to have 2 square here, so that when I compare these two numbers, okay, my LCM, which is the case where I take the higher power, right, then I must have 2 square here, because I put 2 here. Am I correct? But if I were to do that, right, then originally there should have been a 2 at the HCF. Because I have 2, you have 2, there must be a 2 here, right? So 2 cannot be chosen here. Okay? So if 2 cannot be chosen here, I cannot choose 2. I have to choose 5. Okay? 5 already settled. Correct? Settled already. So it must be 3 to the power of 5 here. No choice. It's a case of no choice. Alright, so this is one of the answers. You're going to find the value. Okay, now we do the second one. I erase this, okay? So you know that minimally, this second number must have 3 to the power of 4. Can be higher than 4, but minimally must have this. It must be the 5, must it have a 5? Later I tell you, okay? It must have a 5. Why? Because if no 5, then it will not be HCF already. Okay, so must have a 5. No choice one. This 3 to the power of 4 and this 5, no choice one, both must have for HCF to satisfy this HCF condition. Okay? Now, can I write 3 to the power of 4 here? Can, right? I cannot write 3 to the power of 5 here. If I write 3 to the power of 5 here, taking the HCF of these two numbers, this should have been 3 to the power of 5. So this fella die must be 3 to the power of 4. Okay? Then now what do I lack? I lack this fella. I must have 2 square here in order to make this appear at the LCM. Okay, so now we we work forward now. Like just now we work forward, right? We work forward. This one, given two numbers, then we find the HCF, LCM. We see whether they match or not. Okay, let's say given these two numbers, can you find the HCF? This fella no 2, you got 2, cannot take the 2. This fella got 3 to the power of 5, this fella got 3 to the power of 4, take the lower power one for HCF. Done. This fella got 5, this fella got 5, take the 5, so HCF can. Is correct. Okay, now let's do the LCM. Take the bigger power here, bigger power here, bigger power, both same, we just take. Okay, so this is your answer. That's all.